Okay, as I stated in the previous section, make sure you review these examples that show you the difference between a future value and present value annuity. But we're going to just go ahead and start with some examples. You can go ahead and read how I developed the formula for present value annuity, but that's not necessary in order to actually solve present value annuity problems. Basically, all you have to know is two formulas. This is the formula for solving the present value of an annuity, and then we have another formula that if you wanted to solve for the payment given the present value of an ordinary annuity, then you could use this formula. So these are the two formulas that we're going to work with in this section. Okay, so first of all, number one says how much money must you deposit now? So we're making a one-time deposit now, and it's going to earn 6% interest compounded quarterly. But here's the deal. Here's what makes this a present value annuity. What you want to do with that money is you want to withdraw $3,000 at the end of each quarter for 2 years. Now, if you think about it, that means you're going to withdraw a total of $24,000 because it's 8 withdrawals of $3,000. That's $24,000. Pretty simple. But the point is that you don't need to deposit $24,000 now. You actually can deposit less than that, because as the money sits in there, as you take money out, the money that's left in there is going to be earning interest. So you don't really need $24,000. So we want to find out what minimum amount we can put in there so that when we withdraw that last withdrawal, we won't have any money left. So since these withdrawals are going to decrease the balance, as it says here, since they're going to decrease the balance, this would be a present value annuity. So we want to know what's the present value of these payments, these $3,000 payments that are going to be paid out of the account to us. In other words, reducing the balance that's in the account. So we're going to use this formula, present value formula, where you're solving for present value given the payment. Now we know the payment is $3,000, so we're going to put that in right here. And we also know up here, if I can find my cursor, all right, so the rate is 6% compounded quarterly. So if we take 6% divided by 4, we get 1.5% or 0.015. So notice I just put it in the formula as 0.015 rather than in fraction form, because 0.015 is exactly the same as 0.06 over 4. So I have, notice this formula is a little different than the future value. It's parentheses 1 minus, and then another parentheses, 1 plus I, raised, put another parentheses, and then raise it to the negative end. Now, how did I get 8? Well, it's 4 times a year for 2 years, so that's 8 periods. So that's how I got 8. And then, of course, you're going to divide the bottom by I as well. So again, just straight from the formula. Plug this in your calculator. Get 22,457.78, and again you can calculate how much interest the account earned, as because when you put this 22,457.78 in the bank now and then start withdrawing these $3,000 payments, it's actually going to earn interest. If you want to know how much interest is earned over the 2 years, just take the amount that you're going to withdraw, which is $24,000, subtract what you deposited, what you deposited, and then that will give you the interest, $1542.22. Another example of present value annuity is calculating the monthly payment on a house or a car. So let's look at this one. A bank loans a family $90,000 at a 4.5% annual interest rates to purchase a house. The family agrees to pay the loan off by making monthly payments over a 15-year period. How much should the monthly payment be in order to pay off the debt? Well, you're going to be making monthly payments. Ignore this is a typo. You're going to be making monthly payments, and so these monthly payments are going to decrease the balance. So as you make your payments, it's going to decrease the balance. So that's why we have a present value annuity. Okay, now we know the present value of the home. That's whatever we're financing. So if this was a car, whatever you're financing for the car, if you were buying a car that cost $90,000, it'd be the same thing. So $90,000 is the amount we're financing. Now, we know the annual interest rate is 0.045 or 4.5%. So the rate per period would be 0.045 divided by 12. And I'm just going to leave that as a fraction. Now, we're going to finance it for 15 years. Well, since we're going to have monthly payments over a 15-year period, that's going to give me a total of 180 periods. Okay, so now what am I looking for? I'm looking for the payment. I want to know the monthly payment. So I use the payment formula from the present value formulas. So now I've got the payment. Notice it's just like this, except the fraction's flipped over, and on the right I have present value instead of payment. So now present value, what's the present value of the home? It's the amount you're financing. We did not make a down payment, so since we didn't make a down payment, we're financing the entire $90,000. Just a note, if you had made like a $10,000 down payment, then this would be $80,000. Okay, so $90,000, and now I is 0.045 over 12, and then the denominator would be 1 minus 1 plus 0.045 over 12, raised to the negative 180. N is 180, but the formula says it has to be negative, so we have a negative there, negative 180. Okay, notice I put parentheses around the entire denominator so that it would calculate it correctly, and I get a monthly payment of $688.49. So now, aren't you happy? Now you can take the information you have, whether it's a car or a house, and you can determine your monthly payment all by yourself using this formula. Okay, on this problem, I want to focus on just the amortization schedule. So you can read the problem, pause the video if you need to, read the problem, and see that I calculated the monthly payment on an automobile that valued at $19,500 at 6.9% interest compounded monthly for 48 months. But anyway, the monthly payment is $466.05. Now let me show you how you calculate the amortization schedule. Now this first column over here, you don't really have to put this, but this just shows you the payments, just numbers the payments. So the first, when you make the purchase, you generally don't make a payment, you're not charged any interest, and so therefore there's no reduction, and therefore your unpaid balance when you first buy the car is $19,500. Now when you make a payment, you're going to make your first payment at the end of the first month, which is $466.05. Now here's what's going to happen. The finance company is going to take your principal of $19,500. They're going to multiply it by the annual interest rate, which is 0.069, and then they're going to multiply it by the time for that 1 month, which is 1/12 of a year. And so in other words, that's why I'm dividing by 12, because it's the same as multiplying this by 1/12. So if you take $19,500 times 0.069 times 1/12, you get $112.13 interest that you owe the company. So when you make that payment, the company is going to subtract, they're going to subtract that 112 interest, and then they're only going to apply the difference, which is $353.92. And some people call this principal, some people call this the balance reduction, but what it's going to do is this $353.92 is going to be applied to your unpaid balance. So if you take $19,500 and subtract that, you're going to get your new balance of $19,146.08. So that's what you owe after the first payment. And then you do it again for the second payment. So for the second payment, your interest charged on the second payment, you take this balance, now $19,146.08, you multiply it by 0.069 times 1/12, and you get $110.09. So your interest went down just a little bit. So now when you make your payment of $466.05, they're going to subtract $110.09 from that, and they'll put that in their pocket. And then the difference, which is $355.96, is what you subtract from this to get your new balance. And then you can do it again with this number. So take 18,790.12, multiply it by 0.069 times 1/12. And when I did that, I got 108.04. So I subtract 108.04 from 466.05, and I got 358.01. And then I subtracted that from the previous balance and got 18,432.11. Now, obviously, this would be crazy for me to ask you to do this entire table, because the table would have actually 45 more lines in it to finish it out. But if you go to bankrate.com or just Google amortization table on the internet, you can find several places where you can actually put in the amount financed and ask it to show in the rate and the time period, and you can ask it to show you the amortization schedule, and it'll actually show you a table similar to this. Okay, in this section I'm going to do one more problem, then I'm probably going to have to add another video to finish it off. So let's take a look at number 4. Number 4 says your parents give you $10,000. Well, actually they don't give it to you. Here's what they do. They put it in a college trust fund, and that's going to be paid to you in equally quarterly installments over a 5-year period. Now, so the money's going to earn 1.5%. Now here's something that's tricky. In the past, I've given you the annual rate and you've converted it to the quarterly rate. Here, I'm giving you the quarterly rate. So this can be tricky, because what students like to do when they see this, they just see the rate, and so they'll take the rate and divide it by 4, which would be incorrect. So I is actually 0.015 here, not 0.015 over 4, because you're given the quarterly rate, not the annual rate. So the annual rate's actually 6% if you did some simple calculation. Okay, now, so basically we want to know what payment you can withdraw from this account so that it'll have a 0 balance at the end of the 5 years. Okay, so we take our amortization formula, because that's what we're using here, and we want to find the payment. So the present value is $10,000. I is 0.015, and then the denominator in parentheses would be 1 minus 1 plus 0.015 to the negative 20. Now, of course, it's 20 because it's quarterly payments over a 5-year period, and 5 times 4 is 20. And then when you put that in the calculator, you're going to get 582.46. And so that's going to be your, you can take $582.46 out every quarter over a 5-year period. So it's not a whole lot, is it? But anyway, maybe you can get them to put more money than $10,000 in the trust fund. Okay, that's pretty much all we can do on this video. So I'm going to finish off this section on present value annuities on a second video.